Okay, so this is a Physics 1 exam that I found from UF. I believe it is 2019, if I remember correctly. 2017. So I'm going to go through this exam and work through it like I would if I was taking it, and hopefully it'll help make sense for anyone trying to learn this. So question 1 says a rocket is accelerating vertically upward at 9.8 meters per second squared near the Earth's surface. It releases a rock when its velocity is 10 kilometers per second upwards. Immediately after release, the velocity v and acceleration a of the rock are. So the velocity immediately after it's dropped will be the velocity that it has as it's being released, which is the 10 kilometers per second. Now the acceleration will be 9.8 meters per second down, and this will be velocity up. I think of it like a car a little differently. I guess if you had like a pickup truck, let's say, that's an awful truck, but you get the idea, and you're sitting on the back here. If this car is going 60 miles per hour, you're also going 60 miles per hour. But when you jump off of the back of the truck, there should be wheels there too. When you jump off the back of the truck, or you jump across the truck, you're not keeping up with the truck. Even though you're going 60 miles an hour initially, you're going to immediately be beaten by the truck. That's because the truck would be accelerating and you're not going to be accelerating at the same rate that the truck is. If you were, then you would just keep pace with it. So the answer is 1. Number 2, a football is kicked with a velocity v0 at an angle theta above the horizontal. So that's all this is. This is the horizontal here. v0 is the velocity, the magnitude of it, and theta is our angle from a point P on the ground. A player starts to run with a uniform velocity at the same time starting from P to catch the ball. So they're both at the same point is what this is saying. You both start at that point, the ball and the player. And he runs at a particular velocity, and the ball is always exactly above the player until it's caught. If the velocity v of the player is... So we have to find out how fast the player has to go. Well, it has to keep up with the horizontal component of velocity. That's this part. The vertical doesn't really matter. We're just looking at the horizontal part because that's the only velocity the player has. And that part of it is going to be v0 cosine theta. So that's the speed that the player has to go. That's what the speed v of the player is to actually run into and catch the football. So it looks like it's 1 here. A physics textbook is placed on a spring scale inside an elevator. Of the following, the scale showing the lowest reading when in the elevator is... So here's how I like to think about these sort of questions whenever, and these are a common question you might get, is you have a scale in an elevator. I like to think about Newton's second law here, which is F equals ma. Well, what forces do we have? We have the normal force, and then we have our force of gravity, which we'll say is minus mg, is equal to ma. So the normal is equal to ma plus mg. Now the normal is what's really being read on the scale. When we check our weight or you weigh something, you're actually looking at the normal. So I usually solve for the normal and I look at each situation. So if you're moving downwards with increasing speed, think about what that actually means. If you're moving down, right, that means your acceleration is negative. So acceleration is negative. So that means this is actually a negative value. So that's going to make your normal a little bit smaller. If you're moving up, then your acceleration is positive. Let me move these over here. This means acceleration's negative. This means acceleration's positive. So we can already see 2 is going to yield a bigger number than, moving up with constant speed, that means acceleration 0. Number 2, constant speed, acceleration 0. That means that you're going to have mg. But notice that's going to be still a bigger number than 1 because 1 will have a negative acceleration. Now, 3 is the exact same thing. If it's stationary, then that just means this is also 0. That's just another way of saying that. So you're going to get the same. That is also a equals 0. 4, if you're moving upward, that's a positive acceleration. So that's actually going to be our biggest. And 5, again, it's just another way of saying acceleration 0. So number 1 is the correct answer. And that makes sense with what we think about. Like if you're going down in an elevator, you don't feel that same experience as when you're going up it. So that's how I usually like to work with this. And really what we're interested in is the normal. So they've all been 1 so far. A boy pulls a wooden box along a rough horizontal floor at a constant speed by means of force P as shown. F is the friction force, N is the normal, W is the weight. Which of the following is true? So if it's being moved at a constant speed, that means that your horizontal component is 0. Now this has vertical and horizontal. So F here is equal to the horizontal part here. But they're referring to the magnitude of P, it looks like. So the magnitude of P has to be greater than F. If the forces were equal, then they would just continue at the same speed. Now, the problem is that P is at an angle. So the horizontal component, not the magnitude, just the horizontal, is equaling the friction force. So the magnitude, we'll say, is bigger than our friction. The normal. Now let's consider our free body diagram. What do we have? We have, I'll draw it over here. We have a normal, but we also have a component of P and the weight force. Now there's no reason to assume that this box is bouncing up and down or accelerating up and down. So that means the weight force is going to be equal to the normal plus the Y component of the pull. So for that reason, we would say the weight force is greater than the normal force, which is this one. P is greater than F, W is greater than normal. So here it says, again, it basically looks like the exact same setup. Which of the following must be, oh, that's because it's the same question. So let's move on to 5. So it's still the same setup, but it's asking, it's moving to the left, and it wants to know about work. And work is the magnitude of force times the distance times cosine of the angle between the two. So because F is in the same direction, we would say that our work done is positive because that's just cosine of 0. For P, we would say the work is negative. And we would say it's negative because you're moving opposing to the other side of it. And the work done by W, that's perpendicular, right? So you could think of that as being the force times distance times cosine of 90, which is 0. So that one's 0. So we have positive, negative, 0. And lastly, for question 6, it's just going to be reversed. So now it's moving to the right. So we would say the work done by F is negative work, P is positive, and W is still 0. Okay, so hopefully that makes sense. These were just the first 7 kind of more conceptual problems, so I'll do the rest.